think the thing that we've probably learned the most about mass customization is the fact that the inherent value of products, it changes when you're not looking at a copy on the table of just one after the other. The value of the product changes and customers look at that differently.
As you're thinking about creating a powerful brand that connects with consumers, I don't know how else you do it. And it certainly isn't made in China or overseas, because that doesn't add any value. There's no connection there.
Made in Minnesota.
Solutionology is about being unyielding with perseverance to get to the solution.
To not give up and to constantly drive for better. So even when we deliver 100%, I want to deliver 110 next time.
And for me, the constraints of that project are the most important, because that's what drives us to a solution. It's all about painting a picture and getting all the details in.
How do we develop a tool that helps share our journey, educate others, and bring more light to the realities of additive manufacturing? The Solutionology Podcast.
Welcome to podcast number 9. Today we're discussing mass customization, how we've utilized mass customization, what it looks like in different areas of the industry, colors, textures, medical device, and this is our take on it.
Yeah, so we don't have a guest today. It's just the two of us. We can make it if we try, just the two of us. In all seriousness, it's just the two of us. We're going to be talking about mass customization and exploring we've got this other company called Threedom, this other brand, and it's for mass customization. So we're going to explore that a little bit. We get lots of questions about that, and it's something that we built at DI Lab. So we'll cover that today as well. Just the two of us.
So mass customization has a lot of different flavors. It's used in different ways in the industry. It's somewhat of a buzzword today, but the way that we've focused on mass customization for ourselves so far is the cosmetic aspect and the look and feel of products, mass customizing those features to meet individual personalized needs, wants to match the user.
Yeah, so that's one of the great applications for additive manufacturing is being able to tailor the products. So potentially every single product that comes out of the machine is different. And that's one of the big challenges with injection molding. As a product designer, we have to design a product to meet the widest customer audience, to capture as many people as we can. So that often means that we're making compromises. We're getting the middle 80% or the middle 60% of the possible market, and we're missing the opportunity to tailor that particular product to segments of the market, because the mold can only make one version of a product unless it's modular, but in most cases it isn't. It's only one version of a product. And that's been a challenge that product designers have faced for as long as we're looking at mass manufacturing. So with the level of injection molding, or with the level of additive manufacturing today, we can actually meet mass customization, tailor the visuals, tailor the shape and design of a product. And the only constraint there is the design, not the manufacturing method. We have a unique perspective here because we're looking at this through the lens of a manufacturer, DI Labs, and we're manufacturing these goods, and then we're looking at it through the lens of a product brand, and that's Threedom. And running the business case on these parts, on the different product groups that we have in the product portfolio, and having been responsible for business cases for injection molded parts, this is different, right? We have to look at the business case for the Threedom brand differently than we would if we were spooling up with injection molding. And I think one of the biggest things that comes to mind that's often overlooked is the speed to the market and how much quicker you can capture market share with additive manufacturing like this, and how much quicker you can expand your market share with rapid diversification of your product designs. And that's not something I don't think we fully appreciated before getting into this. But there's definitely a case to be made for looking at the business evaluation through a different lens than you would through traditional products.
Yeah, I think for someone who would experience this for the first time, going through it, there has to be a bigger picture, a bigger scope. It's not just one product that you're going to take this approach with, because there's the value multiplies when you're able to apply this process and reasoning across multiple product lines. That's where the value really comes in. It's like with an injection molded tool, you have one part, you've got the tool, you can produce that at volume, and the value there is that you can make a ton of parts with one capital investment. And with the mass customization, the capital investment is into bringing on the platform within your organization. That's the tool. And then once you've got that platform online, now, you're scaling it up, you're adding more to it. It's highly variable, but that upfront cost is really the getting the team on board and setting the platform in place to produce the product. So mass customization is being used in a number of ways in the industry today. I think the most common is medical device, thinking about hip, knee replacement, and other highly customized components that are going into human bodies that are each different. And there's a individual part made for each person. Make sure that fit and finish is right for that individual.
That's a great point. So you're talking about mass customization and medical device that can be low or higher volume, but each product is tailored to that individual, and it's not tied to a specific manufacturing method. So those hip or knee replacements, they could be machined, CNC machined, or they could be 3D printed. In a lot of cases, they're 3D printed today because of the ability to produce them faster. But mass customization's been around for a long time in different forms. The example you raised is a great one.
If we take a step away from medical device, other ways that mass customization's being used today is like with Riddell football helmets, where each helmet is tailored to a user. In that case, those are a resin or a composite material that's being custom form fitted and produced for that individual, that helmet. And then, those are like fit and finish ways to mass customize products so the fit is perfect for the user. And then there's other ways that mass customization works. That's where products are tailored aesthetically or from like a surface finish standpoint, where you can have a great deal of variability out of simple product lines.
So we're getting into personalization visually.
Yeah, where injection molding today, for an injection molded product, that injection mold is going to make the same copy millions, 100,000s, tens of thousands of times, and it may not meet the requirement of all the users in every way. And having that mold be able to deliver that means you either have multiple molds or you have a great deal of modularity. Either way, that tooling cost that's required to create that sort of complexity there's a substantial investment there. So you can get to some customization in an injection molding environment, but there's lots of boundaries for you to be able to deliver that as a new product out onto the marketplace.
From a product design standpoint, that's probably been one of the biggest challenges, is being stuck to a single mold. So not being able to fully define and serve the various segments of a market, where you're trying to capture as much as the market as you can so that you can offset the tooling cost, and just not being able to tailor product. So that's where, from a product designer standpoint, especially a creative aspect, mass customization is really interesting, because now you can really drill down and serve specific market segments and even specific individuals with true mass customization.
It's hard to know exactly what everyone is interested in when you're first launching a product. So customization can be used along multiple lines of the new product development process and product launch, where you could be trialing and testing lots of varieties from a sold product standpoint to see what is the desired one, so that when you launch a final product, you've got a more focused group of product. Or it could be your go-to-market strategy, where you offer that great deal of variety and you stick with a customized platform like Additive to deliver those products in a build-on-demand sort of environment.
in that sort of scenario, you're almost starting to talk about a business model innovation, where in the last scenario you just mentioned, you may launch a product with various different variations, and then as you learn the market, you could actually expand on those variations and learn from the market, serve a wider portion of that market. So now it's like you're looking at mass customization from an adaptive standpoint and adapting to what you're seeing the market trends being.
And the switching costs can be fairly low because you're talking about the digital work on the front end and not hard manufacturing costs changing on the back end.
So this is something that that a lot of people in the market talk about, in the additive manufacturing market. They talk about mass customization and mass personalization. And there's some examples of it, like the Rydell football helmet. To a certain degree, the mass customization is somewhat limited. So there is some design variations, but it's not truly tailored for the individual. So we're getting to the point where we're starting to push the boundaries. The industry is starting to push the boundaries on the degree of customization and personalization. And so a year ago, we recognized that people were talking about this, but weren't really pushing the boundaries. So we started our own effort to develop some of our own products and then apply mass customization to them. And we did that under a brand of Freedom. It's separate from DI Labs, but we developed the products in-house and then launched them.
So we started about a year ago with Freedom, and you experienced a problem with your Jeep, and you wanted to find a way to solve that problem. So let's look at that use case, talk that through, and expand on what the outcome was.
Yeah. So at that point, it was really just it was a concept, right? Can we use additive manufacturing to solve this problem? The problem that I had was I had a Jeep vehicle, and the key fob, believe it or not, was gigantic, and I didn't like it. So I was like, shoot, we can design a new product and we can manufacture a new product. Let's do that. For us, it'll help us. We'll be applying DFAM and additive manufacturing for a real scenario, and it'll allow us to understand what opportunities exist for producing these products for the marketplace and then varying the different options. So we embarked on that. We developed the new fob, and then we released it to the market. And I think initially we had one fob design, and so one physical design, and then we probably had something like hundreds of variations of that fob, visual variations. And we launched it to the market, and it was pretty interesting. Right away we had strong positive customer feedback, and then customers were starting to request different variations of that design from a shape standpoint. Some of them, the shape didn't speak to them. They wanted a larger fob, or they wanted a different geometry. So that allowed us to go back to the drawing board and then start varying other concepts for that fob enclosure.
So with our use case with Freedom, we would use our new product development process. We designed and developed a mechanical body for a key to hold the electronics in the key. And then we developed a workflow in order to change the surface texture and the surface color of those geometries in a large variety. So hundreds or thousands of variations per mechanical base file.
And through that process, we used additive manufacturing for prototyping. We used several different technologies to prototype the different designs. We took the product to market and launched a beta version, basically, to get early customer feedback. We applied those different variations that we had, and then the more feedback that we got, we continued to expand the variation offering, and also evolve that tool that we created to apply the different textures and visuals. Because initially we just weren't sure how many variations we would end up developing, and it was really an exploration. And from there, the tool and the process continued to evolve and expand. Now we've got 9 products. We've got 4 variations of the key fob, 4 variations of the key fob. And then we've got some automotive handles, which we're showing here on the table. We've got some interior trim components, and then we've got some other exterior components. We've got 9 products in total. I checked this morning, and we've got 38,500 digital files for all of these products. So that probably represents something like maybe 30,000 SKUs. So we've gotten to the point where we've developed 30,000 variations of 9 products. They're split up differently, but it's a significant SKU set.
It makes you want to do the math. If you were to make 38,000 and you took a minute to make each of those products, I can't do the math in real time, but that is a long time, even at a minute.
That's a lot of minutes.
Yeah, that's a lot of minutes. Thinking about the scale of it, as we were halfway through this project, we were sort of exploring and finding our own way and writing the rules. And it's like halfway through, Carl was like, man, we need to have colored buttons. And then we need to have variations of the buttons so that the horn on one is red and the other ones are black, or maybe it's white. And going through that process, all of a sudden, a very simple product line that has hundreds of SKUs turns into thousands of SKUs because of all the variations that are allowed as you create that complexity at different levels of the SKU, more or less. So it's like there's details on each of these fobs that we have here that are you would only know if you picked them up and you held them next to the one next to it. You said, oh, this one has a slightly different texture, or this one has a red horn rather than a black horn. And it turns into a sort of an Easter egg hunt as you're working through the products.
So there are some cases where there's only one of a particular product that's out there. Somebody has a one-off because they're the only one that selected that particular variation.
That's right.
Of options, which is it's pretty neat to think. And that was produced right alongside another product, a twin of it, that had maybe 500 variations that were sold. So from our standpoint, it really doesn't, once we had the system in place, it really doesn't matter how many we make.
And when we're working with, when we're showing these to clients and they're looking at them and they're picking through an array of different fobs that are available, we're getting real-time feedback, and they're like, boy, I really like the look and feel of the dimpled texture over the hex texture, and but I want the tire track and I want the red horn. You find that as they're looking at the whole picture, it's like they become very choosy. And if you were to put a uncustomized fob next to a color fob that has all the details on it, it's like we're not talking about price at this point. We're talking about, this is the thing that speaks to me, and I want it because it shows a little bit about me to others without me having to say anything. So it's a neat experience for just to engage with people and have them pick the thing it's like calling to them.
And we didn't expect that initially. So we also have plain black versions of all of the fobs, for example. And we expected that, the initial problem was, let's make the fob smaller because it's gigantic. And so we produced a standard black version, and that's been, that's been a product that's been popular as well. But to your point, seeing how when customers have the option to pick something that speaks to them personally, it's like that's what they gravitate to. And it's really interesting being in front of people versus maybe selling through the e-commerce site and how that different journey takes place. But in 9 times out of 10, when someone has the option to select that product tailored to them, that's what they select. And I'm not sure that, I think looking back, we would have expected that to happen, but I don't think we would have expected to get to the place where we have so many different variations and we're modifying the product in real time based off of customer feedback.
And for that customer feedback to be so, strong. It'll be in some cases if we don't have a particular colored fob with us, they don't want to buy anything. They want that one in that style, and if they can't have that one, then they'll just wait. They need to have that one.
And I know it's gotten to the point now where there's customers that have made requests for specific designs, and they're waiting for that design to become available till they purchase a product. Yeah. So our initial vision was to develop an ecosystem where we could have product that's designed in real time, on the fly, tailored by the customer, and then it goes into our manufacturing workflow and then produced. And we're not there yet. That's still a vision that we have. And there's been so much that we've learned on this journey of managing 38,000 production files. I think it's like 400 gig or something like that, and then 28,000 SKUs. That's been a part of the journey that we didn't expect the complexity of. Even from a product SKU management standpoint, and making all the SKU families structured so we'd be able to build new variations and continue to use the SKU system. So every single product, every single component to a product has a SKU printed on the part, and that's how we track it in our system.
And what's interesting is that, with 38,000 SKUs, this isn't something we're stocking and we're shipping in real time. We're not taking up floor space in order to keep this product on the shelf. As orders are placed, we put these parts into production in real time, and we deliver in a short window in order to get that product to the client. So it reduces our need to pre-run product and allows us to build on demand.
And from a product inventory management standpoint, that really simplifies the process for us, because now we don't have to deal with obsolete products or products that aren't selling as fast as others. We just put them in the system when they're sold, which is, if that's not impossible, it's nearly impossible with traditional manufacturing. You certainly can't fire up an injection mold press and then press out one part and then turn the machine off.
Yeah. So what have we learned along the way? This hasn't been a straight path. 38,000 of anything, it's a tremendous volume. And if we were manually creating the steps and the pieces, it would take years or a giant team in order to bring it to life.
It would. So, we've learned the necessity to have a digital workflow that's tailored to mass customization. There really isn't anything that exists that we've found off the shelf that does this. Of course, we've developed something in-house that manages all of this, and it's still probably more of in concept form, or maybe it's in the validation stage, but there's refinement to take place. The other thing that I've learned in working with wholesalers and retailers is that they're not ready for, as we're talking to retailers, they don't want to manage 28,000 SKUs. That's probably all that they have in the rest of their products that they manage, let alone with just 9 products. So, the system that's out there direct to consumers really isn't ready for that level of customization yet. So that's something that we've had to build and manage ourselves internally through our own e-commerce page. There's a lot involved, right?
Yeah, there's a lot involved. At the front end of this project, we probably invested a month and a half or 2 months just into fine-tuning how the workflow operates to create the digital files. At the very beginning, we were exporting parts one-off for each variation. You start counting at the minutes, like, wow, this one took me a minute and a half, and I've got another 1,000 to do. I simply can't. I'm not going to be here to do this. I'm going to find another way. And we continued to push the boundaries until we could automate that process. We were exporting a part every 15 seconds or 20 seconds, and those could be generated whether we're in the office or not. We can spit in the information, and then what we get is the results of all the digital content that we're looking to produce and sell. What I've learned is, continuing to push the boundaries allows projects like this to become successful. Otherwise, there's no way to right-size them.
So it's really hard. What it comes down to is it's really hard to start to really execute a mass customization initiative successfully, because there are so many components, and because it's so different from how traditional products and traditional manufacturing is managed. Just those experiences, without getting in there and having them, you can assume what you're going to find, but you don't know until you get there. And that's probably the biggest takeaway. But from from a customer standpoint, specifically about the fobs, there are competitive products out there that were on the market when we entered the market with these fobs, and they're injection molded, and they weren't customized, but they were different colors, and they were a lower price than these 3D printed samples or these 3D printed fobs. And what I've learned through this is that there is an appetite for consumers to purchase products that have a higher cost if they're tailored or if they're premium compared to other alternatives. So we've had customers that have previously purchased smaller injection molded housings. They got rid of those and then replaced it with a Freedom fob because it was customized. So that just tells me that there's opportunity in the marketplace to offer mass customization and then be able to capture a new market that you otherwise wouldn't have been able to. And so, for companies thinking about getting into this, the idea that additive manufacturing is more expensive and the workflow is hard, those things are all true, but this allows you to enter a segment of the market that you otherwise wouldn't have entered and be able to capture new market share, learn new lessons from the market, and continue to expand the portfolio. So what started with one fob design for us has now evolved into these 9 products, and it's a full business. So it's operating on an ongoing basis, and there's no way that we would have gotten to the handles and the interior components had we not started with the fobs. So it's like it's become its own product platform that came from customer feedback.
And what we're looking at, we should connect the dots a little bit. What we're looking at is we're looking at consumer products that are highly aesthetic. They have a great look and feel, but this doesn't always align with, what businesses are doing out there. So, we've got textures that look cool. We have colors that look cool. There's an opportunity to apply this process to functional goods that are industrial, that are commercial. If you need an ergonomic texture to ensure grip in the case of your product, or if you need language or text in your product so that it's communicating a safety feature, all that can be applied in the same way that we've done these colors. So where we've taken a very focused approach on having cool and fun features here, the same process can be applied for ergonomic and safety components that are encoded right into a part. And you have enough variability either for testing or for different markets where you need some customization to meet that market demand.
I'm pretty sure that the color products that are on the table here are not serialized, but each product has its own SKU on it, right?
That's right. Yeah, both the front and the back of these products all have identifiers. They could be serialized as well. We don't need serialization for this. Version control and SKU number control is enough for us to know that the part that we have in our hand is the current version. And if we have to make any changes, we're able to update that.
What you just said is something that's pretty significant. So that fob that you just picked up that's got the SKU in it, there's a version number built into that SKU, right? Yeah. So if for whatever reason we needed to make a design change to the base housing, the geometric design, that has to get propagated back to all those 8,000 SKUs, all those design production files. So that's a significant undertaking, and then the SKU needs to be updated with the new revision.
Yeah, in a typical business today, if you were updating those versions on 8,000 products that all had to be created, that process could be. It could break the system if you aren't ready to manage that volume of SKUs. But with the process that we've created, it's somewhat straightforward, somewhat easy, where we're able to plug in the new values, update the new file, and then we're able to generate those models with very little hands-on time.
And so we don't use a PDM system for that, but even a PDM system really isn't set up for that type of workflow.
To the degree that we're managing these and how we're managing them, there's not a PDM system out there that's going to control the textures and the colors and the way that we're controlling them.
So there really isn't anything that exists off the shelf besides enter, wait a minute and a half, enter, process the next one. It didn't seem that hard when we started it. But in hindsight, hindsight's always 20/20. It's obvious in hindsight that, of course, it would need to have that sort of thoughtfulness built into it. So today, we've got things like this handle, for example, that has its variations are limited to the surface textures. And this is a leather texture. We've got, I think that's snake skin, and then dragon. We've got dragon for the black handles. And then, of course, the Freedom logo, geometric logo. But today, we're limited to the surface textures, and we're not doing full personalization. So we're not enabling customers to upload geometry and make their own texture. That's something that's coming. We've had a lot of requests for different, unique, one-off textures. And I think that's the next step for us in this journey, is taking these base product designs and then making them so our customers, Freedom's customers, can go onto the site and put embossed logos if they want to emboss a logo, or if they want to make their own pattern, that they can do that. There isn't a tool that's really available today, and we've started down that path, but we're not far enough to make it commercially available. Where do you see that going, and how do you see that impacting the digital and manufacturing workflow from how we operate today?
The neat thing about additive is whether that SKU is whatever the number is on the back of this, or whether it's a one-off SKU, it's the same for us. So this part will go into the system, and if we have a one-off part that we make, or if it's a version that we produce that we've designed, there is no difference there. We'll make whatever the geometry is, and we'll make that a one-off, or we'll make 10 of them, or hundreds of them, or thousands of them. So for us, we're able to manage the complexity on the manufacturing side with relative ease, because we have tools to organize and control those on the production floor.
So we built a manufacturing system to be able to manage and track product through the manufacturing process. And at this stage, it's just a matter of getting the existing digital files so that they can be manipulated by customers through a digital interface, through a website, and then get that submitted into the production queue. And then when it's in the queue, it just follows our normal processes.
That's right.
It sounds simple enough. Maybe we can start that like next week.
Yeah, part of the challenge for us is, as we work with all these textures, is we're really creating internal constraints and rules about creating a texture that looks good, that we can apply to a product. We're version controlling everything from the base geometry to the texture to the color. So there's a lot of version control that we're creating a data set that allows us to apply this to a number of things and build a library of information so that we can support our clients, including Freedom, in launching new products and not having to start from scratch. We're building our own ramp here with the data and experience that we've been going through. So we've got a lot of great experience where we're not starting from square one and managing this level of complexity within products.
No, it's really, when you start to look at some of these products and how the texture, these are functional parts that interact with other components on the vehicle, right? And it's really interesting how the texture is added to the part and where the cutoffs are. So there's clearly some intelligence put into where texture is and where texture is not on these parts. And so as we're customizing product, it becomes really important to identify those constraints that you're talking about, so we know what makes a part good and what makes a part bad.
Yeah, we know as we're starting a new product line, we define those constraints along the way. Where do we want to apply texture? It's a marketing question. Where are we going to put texture? What textures do we want to apply to this product? And the same goes for color. What colors are going to be applied to the product if it's a full color part? And what other information do we need to satisfy both manufacturing and the marketing demand? So early in the process, we're defining those key constraints, and that allows us to go through the workflow with as little rework as possible.
And these were, everything on the table was manufactured with multi-jet fusion. Either the mono, it's often called mono, but parts start out gray and they can be vapor smoothed and dyed black. And then of course we've got a few products that were made on the ultra white technology, ultra white MJF. And then we've got all of the fobs that were produced on the full color multi-jet fusion. So everything here is multi-jet fusion, high quality, durable goods. This can be used, mass customization can be served with many different additive technologies, right? Not just multi-jet fusion, and we have internally.
Yeah, so for the use case, of course, we're going to apply the product to the right technology line. In this case, we're looking for very high detail. We're looking for a material that can smooth and be sealed on the surface when it's all done. So we've embarked on Threedom. It's been over a year and a half now, coming up on 2 years since we've launched Threedom.
The first product we shipped was April 5th. I looked that up.
Oh, wow.
Over the weekend. Yeah, so April 5th, 2021.
We're getting close to 2 years. So if you think back 2 years from today, well, if you could send yourself a message, what would you tell yourself?
That's a really good question. We didn't know what we were getting ourselves into when we started this. So I would be afraid to give myself a message about the complexity of the project. But I'd say that the opportunity is bigger than we expected it to be in terms of starting this. We started this as a concept and didn't know what would come of it, to sell anything or nothing at all. And it turns out that it's expanded in a way that we didn't expect. And that's a journey that I think we had to learn in order to fully appreciate. But now that we learned that, I think I probably would have maybe said to start earlier on the process and the software, the digital workflow side of things earlier than we did. But at the same time, I'm not sure how we could have, because we had to go through that learning lesson to spool up.
Yeah, chicken or the egg. There's no way that without a real use case, developing that process is impossible. So while our approach may have been took a little longer than we expected, and it was really challenging, it's from our point of view the only way to approach a complex project like this.
Yeah, right. So we had to learn it. And so as you have projects where you're contemplating mass customization, and you can certainly build the journey that we built ourselves and start from scratch and learn it all. But we've built a lot of understanding and experience from going through this journey ourselves. We've got the additive manufacturing capabilities. So I guess if you're exploring this, contact us. This is something that we can help with. We can help you build a plan. We can help you with some of the identifying where the pitfalls are going to be, and then even providing some guidance on where there might be value and where there might not be value in the market for additive. The thing that I would advise against is going into something like this and looking at it purely through the lens of comparing injection molding costs to additive manufacturing, because I think you're missing the boat. The picture is bigger than that. And I believe that mass customization has to be looked at through the lens of business model innovation, not comparing part costs of injection molding to additive, because those two things, I don't think that's the right way to look at it.
I think the thing that we've probably learned the most about mass customization is the fact that the inherent value of products, it changes. Yeah. When you're not looking at a copy on the table of just one after the other, the value of the product changes, and customers look at that differently. And that's probably the biggest piece. It's like an injection molded part only has as much value as the one next to it. But when you're looking at one-offs or one of very few, the value of those products are perceived differently. And that's the big piece, the big takeaway that I have out of going through the venture with Threedom. We worked really hard to create the process, figure out all the road bumps, but seeing the excitement and the joy in someone's eyes when you've got that rainbow colored fob or you've got that flag fob. I mean, it's unlike anything else.
You know, that's a good point. And so the look on, even if you don't see the look on our face, you know it's there because we have seen it. And it creates a connection, a personal connection with our brand that can't be connected with just an injection molded product brand, that they all look the same. And so that's been the other thing that's been really powerful, is just seeing how our customers, 3M's customers, have connected with 3M, and they become lifelong customers. So as we launch new products, you know, they're there at like the front of the stage saying, yeah, I want the, you know, I want X, Y, and Z texture on this one. And, you know, in some cases we've named the product, some of the product designs after our customers. I think the dog paw was one that someone wanted a dog paw on something, so we ended up naming that product after them. And now, you know, they own that product. They're advocates of it. So you just can't do that with any other products. So as you're thinking about creating a powerful brand that connects with consumers, I don't know how else you do it.
I agree.
And it certainly isn't made in China or overseas, because that doesn't add any value. There's no connection there.
That's right. Yeah, made in Minnesota.
Yeah, made in Minnesota. So made in the U.S. is really important as well, and that's something that makes a ton of sense to do with additive manufacturing, is to make stateside closer to where the market is. So thanks for joining us on this podcast and experiencing 40-some minutes of a year and a half or 2 years worth of journey. And hopefully we get to work with you, and let us know if you have any questions about mass customization, and we'd be happy to help.